We discussed arc length when we were defining radians. If we want to know, if we know either the angle or the arc length or the radius, we can find the third item. I defined the angle theta in radians as the ratio of the arc length to the radius. Now this also means if we multiplied both sides by r, we would find that the arc length is the radius times the angle in radians. We have to use radians with this formula. So if we wanted to find the radius of a circle that has an arc length of 2 feet given an angle theta of 1/3 radian, now let's see, if we solve this for radius, we would get that the radius is the arc length divided by the angle. The radius would be 2 feet divided by 1/3 radian. And when we invert and multiply the fraction, that ends up being a 6-foot radius. Let's try another one. Given a radius of 5 miles and an arc length of 3 miles, what is the angle? So theta, we know from before, is the arc length divided by the radius, and 3 miles divided by 5 miles gives us the fraction 3/5. Theta is 3/5 of a radian. Notice there's no pi here. Pi only shows up when we have angles in terms of pi. In this case, it's just a straight ratio, 3/5. Let's look at one more. In this case, we have a radius of 2 inches, and our angle is 30 degrees, and we're looking for the arc length. We want very much to take the 2 times the 30 and get 60, but that's not correct. This angle needs to be converted to radians, and when we multiply this by pi over 180 degrees, we get that the angle is pi over 6. Now we can multiply 2 inches times pi over 6. That gives us pi over 3 inches. And because we're talking about a length, we don't need to keep this exact. You're not going to tell a carpenter, hey, I need you to measure these out to pi over 3 inches. So we can go ahead and plug this into our calculator, and we'll be told to round to the nearest whatever hundredth, and that'll give us a value of just a hair more than 1. Remember from grade school that the area of a circle is pi r squared. That's for the area of a whole entire circle. Now if we wanted to know the area of a sector, for example this area, what we need to do is figure out what fraction of this circle there is. That's easily done. We take the theta, the angle, that's what we've got. A full circle would be 2 pi, and when we multiply this together, the pi's divide out. And what we end up with is the formula for the area of a sector. I do this little thing just to say that it's a sector. And that formula is 1/2 r squared theta. And again, theta has to be in radians. So let's try one and see what we get. What's the area of a sector that has a radius of 10 meters, so r equals 10 meters, and has an angle theta of 1/2 radian? Well, my formula says I need to take the area is equal to, this 1/2 goes along because that's part of the formula. Then we have the radius squared, so we'll have a 10 squared, and then we'll multiply that by the angle, which is 1/2 radian. Now the 10 is in meters. When we multiply this out, we get 100 divided by 4, which is 25 meters squared. Don't forget your units.